This is the integrated 310.1.2 lecture. So I'm just going to go over one problem, kind of like what you guys would do in your teams, but I'm going to make it a lot faster. So the problem is 10-24, and it says, do you think Antonio's method can be altered to calculate the sum of an arithmetic series without drawing a graph? And I'll show you about the graph in a minute. Work with your team to determine the dimensions of a rectangle that can be used to represent each arithmetic series below without graphing the series. Then calculate the sum. So you might not know what Antonio's method is. I think Antonio likes to find the terms of the sequence and then graph them like with a little bar graph. And then he takes the taller half of the sequence and flips it upside down. And you'll see that he ends up with this rectangle right here. And we know that the area of a rectangle is length times width, or base times height. So I'm just going to go kind of slowly through this one problem. And hopefully by the end it'll make sense to you. So he gives us, we're given this series, and it starts with an 11, and then an 18, and then a 25, and then a plus ... and we end at 74. And so if I wanted to make a table for this, then I could notice that if I just add 7 each time, this is kind of a linear thing. So I'm trying to get a little formula that will help me to find the next terms. I could just keep adding 7. So if you keep adding 7, you go 25 plus 7, you get the next one, plus 7, and you get the next one. And eventually you'll end up at 74. But if you wanted to go a little bit faster, then you could remember that since it's adding the same amount each time, it's linear. So you can think about y equals mx plus b. And then to figure out b, you can count backwards by 7. So if I count backwards by 7, then I would get 4. Okay, so that's b. That's the 0th term. So, and then I know that the slope is 7 because it's adding 7 every time. Okay, this should work for any term that I want of my sequence or my series. So, and I can test it out. Let's see if I get 18 if I plug a 2 in there. 7 times 2 is 14, plus 4, that's 18. So test it out, make sure it works. Then I would like to know, without having to add 7 over and over and over again, I would like to know what term is that? Is that the 100th term or the 5th term or the 10th term? I know it's the 10th term because I already did the problem, but oh yeah, here's another way to write. This is how you write it if it's just a linear equation. This is how you write it, use some n's. If it's a arithmetic sequence. Here's another way to write it. You'll notice that this one, I'm using the first term here. See the first term? So then I wouldn't have to go backwards and find out what b was. But you'll also notice that if I were to distribute this 7, I'd get 7 times n, and then I'd get 7 times -1 is -7. Well, what's -7 plus 11? I think it's 4. So these are equivalent. Okay, here's how I find out that 74 is the 10th term. I get my y equals mx plus b, and I plug in 74 for y, and then I'll find out what x or n is. So I can subtract 4 on both sides, and then I can divide by 7, and I find out that this is the 10th term. And then let's skip to down here. So let's say that I know that I can use this little formula, the little y equals mx plus b. I can use that to get all the terms, or I can just simply add 7. When I get all these terms, I don't know, I showed some of you this. I showed this to some of you. Because it's linear, if I add the first and the last terms, I get whatever 74 plus 11 is, 85. I get 85. But because 18 is 7 more than the 11, but 67 is 7 less than the 74, I hope this makes sense to you. If I add the second and the ninth term, it's going to also add up to 85. I hope this isn't blowing your mind. If it's just because the reason that this works, all these pairs are going to add up to 85, and the reason it works is because this one's going up by 7, this one is going down by 7, so 60 and 25, that makes 85. Every single one of these little pairs, so like this one and this one, this one and this one, they all add up to 85. So if I wanted to add up the series, I could go 85 plus 85 plus 85 plus 85 plus 85. Or in other words, I could say there's 5 sets, 5 pairs of 85. So all I have to do is just go 5 times 85. So let's show how that works with this is like a formula you can use for any series. Remember I said there was 5 pairs? That's because, you know, there's 10 numbers, and if I pair them up, there's going to end up being 5 numbers. Okay, so it's n over 2. It's half the number of pairs, or it's half the number of items you have in your sequence, times the first plus the last. Why is it the first plus the last? It's because that's how I got my first, that's how I knew each little pair added up to 85. I grabbed the first term and the last term. That's all I need to know right there. All you need to know right here. That's your formula. Okay, so I hope that makes sense to you. And then also, so here's the graph that they keep referring to in your book. I just took all my numbers from my table, and I graphed them on this graph. See, like the first term's 11, the second term is 18, the third term is 25. So, what was the kid's name again? Antonio is saying that he can make a rectangle out of these. So if he takes these ones right here and just leaves them right there, he leaves them there, and then he stacks these ones on, like, see how, what would they add up to? 85, right? If I took this really long bar right here, the 10th term, and if I picked it up and put it on top of this bar, it would be about that tall. Okay, and then it wouldn't be there anymore. It'd be gone. Okay, and then each one of these would stack up like this second bar right here. If I stuck it on top of this second shortest bar here, I hope this makes some sense to you. Okay, that was the 9th term. I stuck it on top of the third, wait, no. I stuck the 9th term on top of the 2nd term, and I stuck the 8th term. And we end up with this rectangle. Okay, there's this rectangle. Sorry, it's not a very nice rectangle. So the dimensions of my rectangle are 85, like from the bottom to the top is 85, times 5. So the area is 80, whatever 85 times 5 is. Well, that's 425. I don't need to draw this graph to get the number. So this right here is your formula. So now let's try it. I hope that makes sense. Let's try letter B and letter C a little faster. So letter B says, without drawing a graph, can I sum up 14 terms, and the first term is 8, and the 14th term is 141. Well, I know that this is my formula, so I know there's going to be 14 terms, and they're going to pair up, though, and they're all going to pair up, and each pair is going to add up to whatever the first one plus the last one equals, which is 8 plus 151. So, see, I just used my formula. So it's n over 2 times first plus last. Pretty easy. Okay, then they try to trick you a little bit. So they have t of n equals 6n minus 2. That's how you can figure out the terms, because we know they're linear because they're arithmetic. I want to sum up the first 25 terms. Well, here's my formula. I know I need the first term plus the last term times however many pairs of them there are. So how do I get my first term? Well, I can plug in a 1 right here. And I found out my first term was 4. And how can I get my last term? Well, I'll plug in a 25. That's just where am I getting these numbers from? Just plugged them in right here. 6 times 25 minus 2. And that's 148. And then how many terms are there altogether? There's 25. If they're paired up, there would just be like half of that, so 12.5 or 12.5. And that's the sum of the sequence. Hope that made sense. Talk to you later.